Welcome. So in this lesson, we're going to be talking about determining transformations. Now, in previous lessons, we've learned how to apply transformations, but what we're doing when we're determining transformations, the way I like to think about it, is it's almost like we are a detective and we've arrived at the scene of the crime and we now need to piece together the clues to figure out what happened. So when you are determining transformations, you'll be given a rule of a transformed function, and you have to find the sequence of transformations that took place. So previously, in previous lessons, we were creating a transformed function. We were applying transformations to create a transformed function. But when we're determining transformations, we're going to be given a rule of a transformed function, and we need to find the sequence of transformations that have taken place. Now, when we're doing this and we're reading off transformations, we usually follow this order. Dilations, then reflections, then translations. You can think about it as Dr. T. That's the order that we read off our transformations in, and that's going to make more sense as we continue through this lesson. Now, the first way of determining transformations, is to do so by inspection. So, in order to do this, we need to know a few things. First things first, if we have a function plus k, so plus a number, we know it's going to be a translation of k units in the y direction. So that means it's moving it up or down. If we have x plus a number, then we know it's going to be a translation of k units in the x direction. So that's moving it left or right. And remember, this is where we have to be careful. If it's positive, that means it's moving in the negative direction. And if it's negative, it means it's moving in the positive direction. If we have k times a function, we know that it's a dilation by a factor of k from the x-axis. And if we have k multiplied by x, we know it's going to be a dilation by a factor of 1 on k, so the reciprocal of it, and this time from the y-axis. If we have a negative in front of our function, it's a reflection in the x-axis. And if we have a negative in front of our x there, let me try that again, in front of the x, we know it's going to be a reflection in the y-axis. Now, when we are determining transformations by inspection, you must ensure you factorize inside the function first. And we're going to be going through why that's so important very soon when we go through an example. Now, this is the first way of figuring out determining transformations. You can do it by inspection. So this is one option. One option is to determine transformations by inspection. The other way to do it is to do it by the method. Now, we've seen by the method in previous lessons. And when we're determining transformations now, we go through the same process as we did before in previous lessons when we talked about by the method, but we just work backwards. So a question will say something like this: find a sequence of transformations that takes the graph of y equals x squared to the graph of this right here. So we're going to do the same thing as we normally do when we're doing by the method. We're just going to work backwards. So we've been given the transformed function, and then what we're going to do is we're going to rearrange it like so, and we're doing this in order to get y equals x squared. We then apply dashes. We then equate it to y and x. So as you can see here, we're equating this to y. We're equating this to x. And then you simply rearrange to find what y dash and x dash are going to be. And then after you've done all that, you can simply read off your transformations. Now, that probably made no sense, and because it only really makes sense when we go through an example together. This is just a good reference point for you. So later on, when you're revising for an upcoming test, you can look back here and be like, all right, I remember how we went by the method. So don't stress about this at the moment. We're going to go through an example which will make sense of it. And with that being said, let's go into our first example here. Let's look at this one right here. So it says, find a sequence of transformations that takes this to this right here. Okay, the first way we're going to do this is by inspection. So this is our first way of doing it. So we're going to go by inspection. Now, when we're solving something by inspection, the first thing we always have to do, so remember, this is the first thing you always have to do, take your transformed function and you have to factorize inside the function. What do I mean by that? So I'm going to take it, I've got this, and now I'm going to take 2 out, and that's going to leave me with this. So if I just cast your memory back to all the way up here, where we have this very important line here, which says, when determining transformations by inspection, ensure you factorize inside the function first. That's what we're doing here. And that's why it's so important that you do this. And you'll see why it's very important soon. Okay, after you've done that, now we can just answer the question straight from what we have done here. The way that you read off your transformations is you begin with your dilations. So I have a dilation here. So let's now describe it. So your answer is actually going to be sentences. So you're going to say dilation by a factor of 3 from the x-axis. And then what other dilations do we have happening here? Well, we have this 2. Now we have to be careful with this 2. And by a factor. Now, if it's 2 and it's inside our brackets here, so it's multiplying that x, we know it's going to be the reciprocal of that, and it's going to be from the y-axis. Perfect. So we have now described our dilations. Another important thing here, do you notice how it says sequence? Well, the sequence has order. So that means when you're writing your answer here, you have to make sure that you use the right terminology. What I mean by that is after you've done your dilations, you then have to say then. So then, after we do the dilations, then do this. Remember, Dr. T, dilations, reflections, translation. So the next one that we're going to do is our reflections. And as you can see, this negative tells me that I do have a reflection. So then a reflection in the x-axis. Then we're going to do our translation. So notice the language then again. So our translations are going to be this and this. Now again, we have to be careful when we're reading these off. This right here is going to be 3/2 units in the positive x direction. Then a translation of 3/2 units in the, now you have to make sure you say positive x direction, and this over here is 4 units in the positive y direction. Perfect. And that's our answer. We're done. After we've done this, that is what our answer is going to be. So just to kind of talk about this a bit more, we have a dilation by a factor of 3 from the x-axis and by a factor of 1/2 from the y-axis, and that is by reading off those dilations. We then talked about our reflections, so a reflection in the x-axis, which we read off there, and then finally we talked about our translations, a translation of 3/2 units in the positive x direction, which we read from here, and 4 units in the positive y direction, which we read from here. So hopefully you can see why this is by inspection. We're just kind of looking at it and then straight away writing down what our answer is going to be. Now that's the answer. We're done. Now I want to show you another way of approaching this type of question. So the other way of approaching it is by using, I can zoom out here for a second, is by using by the method. So I'm going to be walking through this process. My notation is going to be a little bit, it's going to be pretty much the same, just the way I set it out is a bit different. And it's just kind of the way I like to think about it, but you don't have to follow me exactly. But let me just go through how I like to think about it. So we're now going by the method. Let me try that again. By the method. Okay, this is the way I like to set out my working, but feel free, if you want to, the working up here is more concise and just straight to the point. The way I like to set it up, it's just the way I like to think about it, and I think it's helpful, but if you think, hey, I think the working up there is more helpful, go for it. This is the way I like to set it up. We're starting with a point, and then we're going to our new point, x dash y dash. So we'll get our original point, and then we're going to our newly transformed point, and this newly transformed point lies on our newly transformed graph. Now, the whole aim of the game when we're doing by the method is to figure out what these two things are. That's what we're trying to do. We're trying to figure out what x dash and y dash are. That's what we're doing when we're doing by the method. That's really important. When we're doing by the method, we're trying to figure out what x dash and y dash are. That's what we're trying to do. The next thing I would do is say, okay, I know that my original point lies on my original graph, which is y equals x squared. And then I know that my x dash y dash point, so my new point, is going to exist on my newly transformed graph, which is y is equal to negative 3, 2x minus 3 squared plus 4. Now make sure you've written that correctly. Good, good, good. Let me just double check it there. 2x minus 3, perfect. Now, perfect. So we've done that. Now I know that this point here, this x dash y dash point, lies on this graph. So I'm going to put my dashes in there. That's my first step. Done. My next step is I'm going to rewrite this. And now I'm going to rearrange this thing right here. And I'm going to rearrange it so I get it into this form. So that means I don't want this plus 4 in the end. So I'm going to minus 4 to both sides. And I also don't want this negative 3 out the front. Now I might do this step by step. So I'm going to get y dash minus 4 is equal to negative 3, 2x dash minus 3 squared. And now, in order to get it into the form that I want to, I need to get rid of that negative 3 at the front. So I'm going to do this. So you could do that in one step. But just because we're new to this, I'm going nice and slow. Y equals x squared is turning into y dash minus 4 over negative 3, which is equal to now brackets. Whoops, let me try that again. 2x dash minus 3 squared. Then I'm going to say y is equal to x squared. And I'm going to get, now I'm going to rewrite this a bit differently now. Instead of writing it like that, I'm just going to bring my negative up the top. And then that's going to become plus, and then that's going to become 3. And that's just a nicer way of writing it, I think. Now, what is the next step that we're going to do? The next step that we're going to do is this. We're going to say, all right, I'm going to let y be equal to this. And then I'm going to let x be equal to that. So let's write out what I've just said there. I'm saying we're going to go y is equal to negative y dash plus 4 over 3, and x is equal to 2x dash minus 3. I now am going to solve for y dash and x dash. So this is going to become 3y is equal to negative y dash plus 4. 3y minus 4 is equal to negative y dash. So that means negative 3y plus 4 is equal to y dash. And then over here, I'm going to go x plus 3 is equal to 2x dash. X plus 3 divided by 2 is equal to x dash. So now I might even do one more step. I might just write it like this. So just so it's left to right. Because why not? In my brain, this just makes more sense. All right, so now that we have that, these are the all-important things that we needed to find. If you remember when we started by the method, I said the whole point of this is to figure out what x dash and y dash are. And you can see by doing this process, we have discovered what they are. So now what I could say is the following. I could say, you know, at the beginning, we started with a point, and then we arrived at a new point. And now we know what x dash and y dash are. I can say that x dash is this, x. Now, I'm going to write it like this. Hopefully that doesn't freak you out. I just broke up the denominator there. So it's x on 2 plus 3 on 2. And then I know what y dash is. Y dash is over here. This is going to be negative 3y plus 4. Now what we're going to do is we are going to read off our answers from this. We're going to read off our answers from that. As we do, we start by reading off the dilations. So this 3 is a dilation. So I'm going to say dilation by a factor of 3 from the x-axis and What is the other dilation that I have here? It is over here. That's the same thing as timesing it by a half and by a factor of a half from the y-axis. Then I'm going to say then, very important word, I'll read off my reflections. So this negative tells me I have a reflection in the x-axis, then a reflection in, whoops, then a reflection in the x-axis, and then after we've read the reflections, we do the translations. So there's one there, and there's one there, and those are telling me I'm going to have, now I might just have to scroll down here, then, make sure you use those words then, so notice I have then, and then again. Then, whoa, I have two T's. Then, a translation of 3 on 2 units in the positive x direction and 4 units in the, sorry, this must be so boring to watch me write this out, in the positive y direction. All right, let's stop and just reflect upon what we did there. Let me do that. So we said a dilation by a factor of 3 from the x-axis, which we read from there. So notice when it's 3 times y, in this case, that means it's reflecting from the x-axis. And by a factor of a half from the y-axis, we read that from there. And then after we read off the dilations, we then read off the reflections. So a reflection in the x-axis, which we can see there. And then after we read off the reflections, we read off the translations. Translation of 3 on 2 units in the positive x direction, which you can see here, and 4 units in the positive y direction, which you can see there. And hopefully you can appreciate that we got the same answer. This is going to be the same as this. So what you'll notice is this is a lot quicker, but sometimes this can be more rigorous and just more helpful when going through it. Hopefully all that made sense and you feel comfortable with doing it both ways. And with that, I will say goodbye. In the next video, we'll go through this question here. You might like to try it before watching the video. See ya.